Hello, folks.
Hey, Igor.
Hello.
Let's wait a few minutes before other people will join us.
Hi, everyone.
Hi, good morning.
Good morning.
Morning.
For everybody who has joined us recently, we're going to start in a few minutes. Just wait for other people to join. All right, so we may start. So today is June 27, and we have a bi-weekly recorded SIG-PM meeting. And today we have several items in our agenda. Let me share my screen, and mostly items related to upcoming 1.7 release. And yeah, the first item that has been added by Garrett is about automatically generated feature report proposal by Dawn. Is Dawn or Garrett here right now? I don't see them, so probably I may skip this item for now. We have also demos for 1.7 features by SIG-apps about stateful sets and daemon sets. Probably that's about stateful set updates and daemon set updates that are notable features for 1.7 release. So any SIG-apps representatives here?
Yes.
Yeah, okay. I'll start sharing the screen now. So who is the right person to start with?
Can you guys hear me?
Yes, we can.
Okay. Sorry about that. I was having a little bit of a mic difficulty. So I'm Ken Owens. I'm on Jago McLeod's team. I'm going to demo the features that we're adding for 1.7 for stateful set, which are pod management policy, and as you already guessed, stateful set updates. So let me share my screen and we can get started. Okay. So can everybody see 4 windows?
Yes, and
That is a yes. All right, so what we're going to demonstrate is pod management policy and stateful set updates in the context of running Kafka. And in order to do that, we have to start a Zookeeper cluster. So the main difference between this and the previous Zookeeper demonstrations we've done is that we have pod management set to parallel. So if I go and create my cluster, what you'll see in the upper left corner is that rather than starting up sequentially and doing one at a time, deployment, waiting for each pod to be running and ready, what it will do now, because of the pod management policy, is launch all the pods simultaneously and wait for them all to come up together. Now, if you're doing something like deploying a replicated MySQL topology, you probably do have to wait for each pod in your cluster to become running and ready prior to launching the next one, because you're going to want to copy over data from one pod to the subsequent pod. But for a lot of distributed systems, I'd probably say most, really it's a pessimism to wait for each pod to be ready. And it can be a burden for people who are deploying the application. If I have to deploy a 300 node Cassandra cluster, and I really don't have to wait for each one to become running and ready before deploying the next one, it's a huge decrease in my amount of work time, my amount of effort, if I could just launch all the pods simultaneously. So Zookeeper's up, and the next thing we'll do is we'll launch a Kafka cluster. The Kafka manifest is about the same. It also has a parallel strategy. And again, you see all of them coming up together, launching simultaneously. And that's basically it for the parallel pod management strategy. Now, we still support the previous strategy from 1.6, and in fact, that's the default. That strategy is called ordered sequential. But, I mean, most people have seen that already, so we're not going to bother demonstrating that here. So go ahead.
Okay. So this demonstrates, for example, that you can now start stateful sets much faster and scale them up much faster too?
You can start them up much faster. You can scale them up much faster. And in some cases, so think of it like this. It's 2 o'clock in the morning and I'm turning up a Cassandra cluster. If I was on Kubernetes 1.6 and I get one failure in the middle of that CM, it's blocked. And I'm not doing anything until I fix that node. And in reality, do I care that one node didn't come up? Probably not. What I really want to do is get 99% of my nodes up. And if I do that, then I can go back tomorrow and figure out what went wrong with that one node. So parallel pod management solves that use case. And on top of that, it's a performance optimization to get that 300 node cluster up much faster than if you had to wait for each pod to come up in serial.
This is awesome. Is there any guidance on what type of stateful applications this applies to, or is that left to the user to figure out, or do we have examples?
It's left to the user to figure out in some instances, but most people who are administrators of these types of applications are aware of the constraints of the particular application. In the documentation, we use Zookeeper as an example, and anything that's basically a distributed state machine that uses a coordination protocol to replicate its state machine, that's going to be a good example. So etcd can use this strategy. Zookeeper can use this strategy. Cassandra, React, you have to be careful with how you do readiness checks, but they can use this strategy. Kafka, because it uses Zookeeper in order to coordinate its nodes, can use this strategy. So, well, actually, technically it's a policy, but it's applicable to a large number of the applications that we've gotten signals that people are interested in.
Great, thank you. It's awesome.
Is there a plan to update relevant Helm charts to use this?
So I actually have the Zookeeper Helm chart, and I'm working on the Kafka one now to use it. We'll probably go back and look at some of the other ones and see where it's applicable, but we have a lot of work to do on curating the Helm charts in the general case to get it ready for 1.7. And the more important feature is the one I'm about to demonstrate next, which is update. So we want to get everything working on that and look at, you know, implementing parallel pod management where it makes sense.
Cool. Yeah, I was just thinking, like, to Aparna's question of, you know, is there a list of like which ones work and which ones don't? Kind of makes sense for that to be like just the programmatic Helm charts. So that's cool.
So moving on to update. Now, let's say I want to do something like do an update of the bits for Kafka, like take it from a minor release version from 10.2.0 to 10.2.1, and maybe give it a little more CPU. For everyone who's familiar with stateful set prior to 1.7, basically what you'd have to do is apply this update and then kill each pod one by one. That's probably not an effective strategy for most organizations. I mean, just think, like, if you were to lose a large portion of your fleet, when it came back up, you're going to automatically apply that update because the stateful set has no notion of the prior revisions of the pods that it contained, right? So, I mean, if you have a large number of stateful sets, you have a large organization, you have a lot of updates in flight, you have an outage that takes down 50% of your fleet, some of those updates weren't going too well, it turns out. You come back up, now you're mitigating an entire another set of outages. Really, it's not a feasible thing for people to do. It's not a feasible strategy for people to update their software in a production environment. By applying this update to Kafka, what you'll see in this window over here is that what we're going to do is we're going to take down each node. We're going to recreate it. We're going to do it in order, well, reverse order. So we'll start with 2, go to 1, go to 0. And we're going to make sure that the update stays consistent, meaning that we're not going to touch Kafka 1 until Kafka 2 is running and ready. We're not going to touch Kafka 0 until Kafka 1 is running and ready. If any of these pods fails in the interim, it's not going to come back up with a new version. It's going to come back up with the previous version. And we'll demonstrate that in just a few minutes as well, as soon as this guy gets up running and ready. But the short of it is, we can now do ordered rolling updates of stateful sets. So you can update the configuration, you can update the bits, you can update the resource requests for any of your stateful applications in a production environment in a safe way. And Kafka 0 is coming back up now. It's about to, it's running, about to go ready. So that's great, but for a lot of people, that's probably still not enough. I mean, maybe it's okay for you to come into work and just roll out an update, let it rip and let it go. But in reality, most people probably are going to stage an update to a lower environment first, test it out, play with it, then move it into a production environment. When they move it into a production environment, they may not want to just blast it out across all their fleet. More likely, they'll probably stage it. And so we have a notion of partitioning an update. And what that means is any pod with an ordinal that's equal to or greater than the partition you apply to the rolling update is going to get it. Any pod that's less than it is going to remain at the same state. That sounds a little bit confusing, so easier just to show exactly what it does. So now I'm going to set the partition to 3. And I'm going to apply it again. So if you'll notice, this time nothing actually happens. I applied it, I've updated my stateful set, but no containers, no pods were updated. And that's because I set the partition to be the number of replicas, meaning that I've staged this update, but until I touch the stateful set and move that partition, it doesn't progress. My update's staged, it's ready to roll out, but nothing's going to happen. And if I go ahead and do something like, let's delete Kafka 0. So I'm taking down Kafka 0. When it comes back up, what you're going to see is that it doesn't receive an update. Basically, I've staged this update, but if any of the pods should get deleted, if anything should happen, it's going to come back up in the same configuration. So if you look at, actually, I should probably have, let's do this. So no matter what you're going to do, you're not going to modify any of the pods, any of their images. You're only going to update, or any of their resource requests, you're only going to update the stateful set itself. If I modify the partition, let's say I move it back to 2. You'll see that it triggers the update for pod 2. So what happens here is anything that's less than 2, Kafka 0 and Kafka 1, if I kill them and bring them back up, they're always going to get the exact same revision they have right now. They're not going to receive the CPU upgrade I just applied. If I kill Kafka 2, it's always going to come back up and get the new revision. And if I modify, well, let's just remove the partition. If I remove it, you'll see the rollout progresses and takes down Kafka 1, brings it back up, Kafka 0 brings it back up. So what this partitioning strategy allows you to do is perform phased rollouts. And you can pretty much do whatever strategy your organization wants. Like if you guys do linear rollouts for one application, it'll work. If you do geometric progressions or exponential progressions, that'll work too. Now, we don't have any higher level controllers that make use of the partition in and of itself. So there's no way I can do like kubectl rollout linear or kubectl rollout exponential, kubectl rollout geometric. But if you have some automation tooling around your updates, you can easily use this to implement your own. And maybe going forward, we can think about, does it make sense to support this as a higher level primitive out of the box? Okay, and
Very cool.
That's basically the feature. Any questions?
I think it's really cool. It's a little bit, I think it deserves a blog post. Are you planning to write one?
So I've been talking with Dan about that. Apparently there is some sort of a plan to write one, and I was thinking that maybe I would do basically a blog with this demonstration showing how to run Kafka on Kubernetes and how to update it, showing updates to the Kafka bits, updates to resources, updates to configuration, and demonstrating staging an update, doing a canary, and rolling out, I guess, a linear progression.
That would be awesome. Yeah, yeah. And there is like a 5 days of blogs happening after the release, so we'll ask if you could write one there. And it would be, yeah, the only thing is I would start with the simple and then show the, like, I would start with just the rolling upgrade and then show the partition and so forth.
Yeah, I mean, that's basically what we did here, right? Like, just start, roll one out, and it works, and that's the big win, right? Because the one kind of, so if you look at Mesos and their stateful application software versus what we had previously, not being able to do rolling updates, to me, was the largest gap. Like, I don't see how you could really have used stateful set successfully without this feature. So I feel like it's a pretty big deal, and just focusing on that is probably enough to engage users. Okay. Janet, are you there?
Yes.
Are there some questions? Oh, and
we don't have any major questions in the chat, but we have asked you about some extra promotional activities on this feature also in the community meeting blog post and so on.
Sure, I mean, that's fine. The other thing is that Daemon Set is also going to demonstrate some other features that are also in stateful set, but we wanted to demonstrate the stateful set specific features kind of first. So,
yeah, perfect.
Love to demo it for the community.
And for clarification, Daemon Sets already has the update feature, right? It already had it before 1.7.
It does. But what I didn't speak to and what Janet's going to speak to is that we also keep a history of the updates and we support rollbacks, not automated rollbacks, but the ability for a user to say, hey, this CM's not working right. I'm not liking what I'm seeing. Roll this back. And we save the prior revision of the pods and reapply it to get them out of trouble in the event that they start. And Janet's going to demo that for you.
Yeah, is Janet sharing her screen now? I suppose yes, as I see name Janet, but can you comment on what you're doing now?
You may be muted, Janet.
Yeah. I've just unmuted Janet, so Janet, if you're here and you comment on your demo, please do it.
Okay, can you all see my screen?
Yes, we can.
Okay. So today I'm going to show you how to do a daemon set rolling update and do a daemon set rolling back. So daemon set already has the rolling update feature in 1.6, and in 1.7 we implement the history for daemon set and for stateful set. And so we also implement the rolling back feature. So in the top of the screen, I'm going to run some commands. And at the bottom of the screen, there's also a window that I'll be watching the creation and deletion of the daemon set pods. So first, let's take a look at the nodes I have in my cluster. So a daemon set will create one pod per node. So let's take a look at the daemon set I'm going to create. It's a node exporter implemented by Prometheus. So what it does is that it will export the metrics of the node to Prometheus. So let's go ahead and apply this daemon set. So in the bottom of the screen, you can see that there are 4 pods being created. And their image is the node exporter, and their node is, they are running on each of the nodes. So we can take a look at the rollout status by running kubectl rollout status. And it shows me that the daemon set is rolled out successfully. And we can also take a look at the raw history by running kubectl raw history. So in here, you can show that there's one revision of daemon set, and the change cost is created from the -- record flag I passing in the when I run the kubectl apply. So it will record the command that I ran when I create this daemon set. I can also do -- revision 1 to look at the details of this daemon set history. And what's inside the history is that the pod template of this daemon set is recorded in the history. That's because when I want to trigger a daemon set rolling update, I need to change the pod template to trigger a rollout. And any other fields that I change will not trigger a rollout. So that's revision 1. So let's say now I want to update the daemon set to another version. So the first daemon set, I'm running version 0.13, and now I want to upgrade it to 0.14. So let's go ahead and apply this version 2 daemon set. And in the bottom of the screen, you can see that the pod is being terminated one by one, and it will be upgraded one by one. So now all 4 pods are, now one of the pod is version 14.14, and now they're being upgraded one by one. Then you can still check the raw status from kubectl raw status. And now it's all successfully rolled out. You can look at the history again. Now it shows me version 1 and version 2. Check the details of the version 2, revision 2. It shows me the version 2 is 0.14. Now let's say I want to do a rollout, but it will fail. What would happen? So take a look at this this YAML file. You can see that the image is, I put that image there intentionally because I want to see what it would happen. So now I do a bat rollout. If you can take a look at the bottom of the screen, one of the pod is being terminated. And now a new pod is being created with the bat image, and the error image poll status is being reported for this pod. Even though this pod failed, the rollout won't progress. So the rolling updates feature prevents it from getting worse. And let's take a look at the raw history. So you take a look at the raw history and you decided that I want to do a rollback. Maybe I want to roll back to a revision 2. Or you can just say kubectl rollout undo. It will by default choose the last revision you have. So now the bat image is being rolled back to version 0.14. And now if you take a look at the raw history again, you can see that the version 2 becomes version 4. That is because we do a rollback by rolling forward. So the most current revision is always the largest number. And after a rollback, that if you, let's say you roll back to version 1 again, it will be version 5. So let's say I do a rollback to version 1. Oh, to version 1. You will be rolling back to version 1. So it will take a while to finish the rollout, but we can take a look at the history now. Now it becomes 3, 4, and 5. That's because version 1 becomes version 5. And if I do a rolling back to version 5, which is the current version, it will just tell me that you are already in the revision 5. If I do a rolling back to a revision that don't exist, it will tell me that it cannot find the revision 100. So that's the rolling update and history and rollback feature of daemon set. And stateful set will use the same history and same command to roll back. So does anyone have any questions?
This is really awesome. So it's really more of a smart rollback, I would say.
Thanks.
Is that fair to call it a smart rollback because it stops if you have an error?
Yeah, and it stops because you specify a minimum, the max number of unavailable pods you can have. So by default, the number is 1. But if you want to be more aggressive, you can specify 2. Then it will be rolling 2 pods at a time. Like it can tolerate removing 2 pods and then create 2.
Great.
It's similar to deployment.
Just one more thing to point out, though. If everyone didn't notice, when she did those updates, it only mutated the pods that didn't already match. Did everyone catch that? So like if you do an update and the pod already matches what you've updated, you don't terminate it and restart it. So in that sense, I would call it kind of a smart update. It detects things that are different from the current specification and only terminates those pods.
Yes.
So any other questions? Anything else to discuss regarding these two really exciting features from SIG-APPs that we are looking at right now? Suppose silence is no, so let's proceed with the next item. Our next item in the agenda is minor but notable one. We already have the first draft of 1.7 release notes, so you may find the link in the meeting notes here. It's still in the early stage and it has to be also updated, but if anybody at this meeting would like to discuss some of the features or some items from the content here, let's do it right now. Probably, Aparna, you may have some questions or suggestions regarding this.
Sorry, regarding which one?
The feature, the release notes draft for 1.7.
Right.
Yeah. By the way, there was a new feature added to our features repo yesterday, just so audit logging. So I guess it's in the release. It wasn't in the features repo, so just FYI. I'll look at the release notes now.
So they're in a very draft form. Aaron was kind enough to go through the feature tracking spreadsheet and take the one-line description from all the features listed there and put them in here. The ask, and I guess the action required, is SIG needs to go through and add additional work that wasn't tracked in the features repo or feature tracking spreadsheet that's of note, particularly any action required or significant changes from previous releases need to be done by the SIG leads. Or
One question I had was TPR is deprecated. Do we have a rationale for why?
There's like a migration path, but I think API machinery needs to fill that out. I don't know. It probably, since it would warrant a action required of a similar size, like similar prominence as the etcd note we had last release. There's no like immediate action. Like you can do it in like two separate like stages. You can like upgrade to 1.7 and then migrate your TPR resources. But those migration strategies should be talked about by someone.
I did see the documentation. I browsed through the migration guide, but the thing I couldn't understand is why is TPR deprecated? Does anyone know?
Yeah, there's a big like thread somewhere. I'll try to find it and shoot it to you. But there was like a big rationale about what was trying to be done for extending Kubernetes.
Okay, I just wondered if there's like a simple explanation we should provide users. We can put it in the blog or we can put it in the release notes or somewhere. Ideally, you know, there'd be some benefits. I'm sure there are some benefits.
Yeah, it would be great. Probably we have API machine representative at the call today, so he may provide us with some updates. So William Dennis is here. William, you're representative for SIG-PM machine. Probably you may provide us with some details on this one.
Hi, yeah, I don't have an update for today, so let me try to go on for 2 weeks from now.
We were wondering why TPR has been deprecated. What's the benefit or so forth? And if you would like, you can get back to us over email.
Okay, I'll take that as an action item.
Yeah, and we have a comment from Foxish in the chat, so if Jason can add it to the meeting notes, it would be great. If Foxish can comment also on this item, it would be great as well. Okay, so it would be great to receive some further details via email on the mailing list regarding this behavior. Any other items to discuss for today regarding features regarding PM process and anything else?
No, this is awesome. And the release notes look awesome. Thank you so much.
Yeah, it would be great if they will be also updated and finalized. I suppose that release team will focus on that in the nearest time. Okay, so thank you for joining us today and see you in 2 weeks on our next meeting. Goodbye, everyone.
Thank you. Take care.
Thank you, Ihor. Thank you for SIG-App's demos.